Tomorrow morning at precisely 11:36 Universal Time, something will happen that we were told would be invisible. An interstellar visitor racing through our solar system at speeds that would make your head spin will swing around our sun at its closest approach. For months, every astronomical source you could find repeated the same story. It will be hidden behind the sun, unobservable. The most critical moment of this object's journey through our neighbourhood, the exact window when any spacecraft would perform its most fuel-efficient manoeuvre, conveniently obscured from every telescope on Earth. But 4 days ago, on October 25th, an amateur astronomer pointed their equipment at the sky and captured something that changes everything. The object they were told would be invisible, sitting right there, visible, observable, next to the sun in broad daylight. Either every major astronomical institution got their calculations catastrophically wrong, or someone wanted us looking the other way. Tomorrow we find out which. Before we dive into what might be the most important 48 hours in modern astronomy, I need to ask you something. If this story matters to you, if you want to stay informed about what's really happening up there, hit that like button and subscribe to the channel. Both help more than you know. And here's what I'm curious about. Tell me in the comments where you're listening from, what time it is there right now, and whether you'll be watching the sky tomorrow morning. Share this on social media if you think others should know, and hit that hype button to help our community grow. Thank you for being here. The lie they told us. Let's start with what we were supposed to believe. Since July, when 3 Atlas was first detected racing toward our inner solar system, the official timeline has been remarkably consistent. The narrative went something like this. On October 29th, 2025 at 11:36 Universal Coordinated Time, this interstellar visitor would reach perihelion, its closest approach to the Sun, at a distance of 1.356 astronomical units. That's roughly 203 million kilometers if you're counting, and on that exact date, the object would be positioned directly behind the Sun from Earth's perspective. Solar conjunction, they called it. Completely hidden, unobservable, no witnesses. This story appeared everywhere. Astronomy blogs picked it up. The Jet Propulsion Laboratory tracking data summaries mentioned it. Amateur observation guides warned skywatchers not to bother looking. Even peer-reviewed papers discussing the object's trajectory included casual references to this convenient blackout period. The implication was crystal clear. Whatever happens during perihelion, whatever changes might occur in the object's trajectory or brightness or behaviour would happen in darkness. We'd have to wait until early November when 3E Atlas emerged from behind the Sun to see what had changed. Trust us, they seem to say. We'll tell you what we found. But here's the thing about trust. It requires honesty. And on October 25th at 13:25 local time, someone decided to check for themselves. The blog post appeared under the name Earth Exists, an amateur astronomy group that had been tracking 3I Atlas since its discovery. What they published wasn't a theory or speculation. It was evidence. Actual telescope images time-stamped, coordinates verified, showing 3 Atlas clearly visible in the constellation Virgo. And here's the part that should make every hair on your neck stand up. The Sun was in the same frame, massive, bright, sitting on the left side of the image. The object they told us would be hidden behind the Sun was instead sitting next to it, separated by a measurable angular distance with the reference star speaker visible for positioning and Venus hanging on the right edge of the frame. Let me say that again slowly so it sinks in. 4 days before perihelion, when every source claimed the object would be sliding behind the Sun and vanishing from view, an amateur astronomer captured it clearly visible alongside our star, not behind it, not obscured, observable, right there. The technical details matter here. The position they recorded was right ascension 13 hours 38 minutes 44.9 seconds, declination 7 degrees 40 minutes 32.5 seconds, distance 2.34 astronomical units, roughly 350 million kilometers from Earth. Apparent magnitude 15, which means you need a telescope to see it, but it's absolutely there. The object exists in observable space, sharing the same field of view as the Sun, completely contradicting the solar conjunction narrative that's been pushed for months now. Before anyone jumps in with explanations about angular separation or solar elongation, let's talk about what solar conjunction actually means. When astronomers say an object is in solar conjunction, they mean it's positioned at roughly the same celestial longitude as the Sun from Earth's viewpoint. The practical definition usually includes objects within about 10 to 30 degrees of solar elongation, the angular distance from the Sun's centre. Below that threshold, the Sun's glare overwhelms everything else, making observation effectively impossible without specialised coronagraph equipment. But here's what makes the October 25th observation so damning. If 3i Atlas is visible now, clearly separated from the Sun in the same telescopic field, then basic geometry tells us something remarkable. The object's trajectory doesn't place it behind the Sun on October 29th. It places it near the Sun, still at an observable angular separation, different from behind, visible instead of hidden, which means either the orbital calculations from every major institution are fundamentally wrong, or the story we've been told about perihelion invisibility was never about orbital mechanics at all. Think about that for a moment. This isn't some minor discrepancy in predicted brightness or a small error in trajectory calculations. This is the difference between observable and unobservable, between witnesses and darkness, between transparent science and convenient narrative. The most critical moment in this object's passage through our solar system, the exact window when physics tells us any technological craft would perform course corrections to maximize efficiency, happens to coincide with a period we were told would have zero observation coverage from Earth. Just a cosmic coincidence. They assured us, nothing to see here. Literally. Except now we know there is something to see. The question is why they wanted us to believe otherwise. The Earth Exist group didn't stop at proving visibility. They pulled up their previous observations from October 21st and 23rd and started comparing notes. Remember, they've been documenting systematic trajectory deviations for over a week now. Position offsets from Jet Propulsion Laboratory predictions reaching 15.4 arc minutes. Lateral velocity changes requiring approximately 3.95 km per s of non-gravitational acceleration. Brightness anomalies showing the object consistently 20 to 26% dimmer than models expect despite moving closer to the Sun. These aren't subtle discrepancies. Arc minutes are big in astronomical terms. 1 degree of sky spans 60 arc minutes and the full moon covers about 30 arc minutes. When an object appears 15 arc minutes away from where physics says it should be, something is pushing it. Something is changing its path. And when that same object brightens faster than inverse square law predicts as it approaches, yet still remains significantly dimmer than models expect, you're watching behaviour that doesn't fit the simple story of a passive ice ball following gravity. The October 23rd, 25th data makes this even more interesting. Over just 48 hours, 3.2 Atlas shifted its right ascension by 3 minutes 56 seconds of arc. That's an increase in angular velocity compared to the previous days. The declination shifted 17.7 arc minutes northward, moving toward the celestial equator. Distance closed by 0.02 astronomical units, roughly 3 million kilometers closer, and brightness increased by 0.0404 magnitudes, about 4% brighter. Now, here's where the physics gets uncomfortable for the natural comet explanation. The brightness increase they measured was more than twice what inverse square law predicts for that distance change. When something gets closer, it appears brighter in proportion to the square of the distance change. Move from 2.36 astronomical units to 2.34 astronomical units. You expect about 0.017017 magnitudes of brightening. They measured 0.04, more than double, while simultaneously remaining nearly a quarter magnitude dimmer than models predicted for October 25th. The object is brightening faster than it should as it approaches, but staying dimmer than it should overall. That's not how passive reflectors behave, and the angular velocity is accelerating. The rate of change in position from October 23rd to 25th exceeds the rate from October 21st to 23rd. As the object approaches perihelion, it's not just moving, it's speeding up in ways that pure gravitational acceleration doesn't fully explain. When you combine this with the persistent lateral velocity component that's been documented for over a week, you're looking at an object that moves more like it's under intelligent control than like it's following a ballistic trajectory. But wait, there's more. Because while amateur astronomers were busy proving that perihelion would be observable, mainstream institutions were quietly putting pieces in place that only make sense if they knew something big was coming. Let's build a timeline of what happened in October leading up to tomorrow's perihelion passage. Start with October 1st. The United States government enters a funding lapse, a shutdown. NASA goes largely silent. Public communications slow to a trickle, and suddenly the most visible space agency on the planet isn't actively discussing the most significant interstellar visitor we've ever had the opportunity to study up close. Coincidence? Maybe. Let's keep going. October 16th. The Search for Extraterrestrial Intelligence Institute, SETI, quietly releases revised post-detection protocols. These are the official procedures for what to do if we detect a signal or presence from extraterrestrial intelligence. They haven't been updated in 15 years. 15 years of silence. And suddenly, 2 weeks before 3, Atlas reaches its closest approach to the Sun. SETI decides it's time to revise the rules. The new protocols create what critics call a communication monopoly, restricting who can discuss or respond to extraterrestrial contact, centralizing control over information flow, establishing clear hierarchies for announcement and analysis. Why now? What changed October 21st? 2 things happen on the same day, and this is where the pattern becomes impossible to ignore. First, the International Asteroid Warning Network adds 3 IATLAS to its planetary defense threat list. Let that sink in. This is the first interstellar object ever designated this way. Not 1I, the first interstellar visitor we detected back in 2017. Not 2I Boris, the interstellar comet that passed through in 2019. Just 3 Atlas. Why the object poses no collision risk with Earth. Its closest approach to our planet will be roughly 269 million kilometers, nearly twice the Earth's own distance. So why add it to a planetary defense list designed for actual impact threats? Second, on that same day, October 21st, EON announces a mandatory training exercise for member institutions. The exercise runs from November 27th through January 27th. 2 months of coordinated training starting exactly 4 weeks after perihelion. Training for what? Processing data from a natural comet or preparing for something else entirely the same day. October 21st is also when amateur observers first documented those systematic trajectory anomalies. Position offsets, brightness discrepancies, behavior that doesn't match gravitational predictions. All of this happening while institutions activate unprecedented protocols. Restrict communication rights, and tell the public not to bother looking because the most critical moment will be conveniently hidden from view. You start to see the shape of something, don't you? Not quite a conspiracy, not quite an accident, but something in between. A coordinated response to something they saw coming, a gentle push to keep eyes elsewhere while they figured out what they were dealing with. A story about invisibility that turns out to be false, told at exactly the moment when visibility matters most. And here's the thing that keeps me up at night. If they were willing to mislead about something as basic as whether we can observe perihelion, what else are they not telling us? What other parts of the 3I story have been carefully shaped to keep us calm, passive, trusting that experts have everything under control tomorrow morning at 11:36 Universal Time? 3Y Atlas reaches perihelion. The Earth exists. Observations prove we can watch it happen. Every telescope on the planet capable of pointing anywhere near the Sun will have the opportunity to record whatever occurs. No darkness, no hiding, just physics playing out in real time with witnesses. If this is a natural comet following gravitational physics, we should see predictable behavior. Brightness corresponding to outgassing rates and solar heating trajectory matching orbital models within reasonable error bars. Symmetric coma structure consistent with sublimation of surface ices. No further course corrections beyond what solar radiation pressure and asymmetric outgassing can explain. Simple, clean, natural. But if this is something else, if even 1% of the technological hypothesis holds water, tomorrow becomes very different. We might see continued lateral acceleration inconsistent with gravity alone, brightness anomalies suggesting controlled emissions rather than passive reflection and outgassing, geometric patterns in the coma that look designed rather than chaotic, potential course corrections during perihelion passage itself, taking advantage of the Oath effect to maximize delta-5 efficiency, and maybe, just maybe, the release of smaller objects, daughter probes, scouts, whatever terminology makes you comfortable using the gravitational assist from our sun to redirect towards inner system targets. Tomorrow, we find out which universe we live in, the one where interstellar visitors are always natural, always passive, always exactly what we expect them to be, or the one where someone else learned to travel between stars before we did, and they're here right now doing exactly what we'd do if we sent a probe to another solar system. Observe, measure, decide. And if it turns out to be the second universe, if tomorrow brings evidence that 3E Atlas isn't what they told us it was, then every lie, every misdirection, every attempt to keep us looking away while the real story unfolded will make perfect sense. 'Cause how do you tell 8 billion people that they're not alone? How do you announce that the universe is full of intelligence and we've just been too young, too isolated, too primitive to notice until now you don't? Not until you absolutely have to. Not until the evidence becomes so overwhelming that silence is no longer an option. Maybe that's why they wanted us to believe perihelion would be invisible. Maybe they needed time to prepare, to coordinate, to figure out how to handle what comes next. But tomorrow, that window closes. Tomorrow we watch, all of us, whether they wanted us to or not, Earth's new moon from the Cold War, while 3I Atlas dominates headlines with its dramatic approach. Another discovery slipped into the astronomical record this summer that might completely rewrite what we think we know about Earth's neighbourhood. On August 2nd, 2025, Carlos and Raul Delante Marcos spotted something that shouldn't exist. A quasi-satellite of Earth designated 2025 PN7 orbiting in lockstep with our planet in a way that natural asteroids almost never do. The numbers looked wrong from the start. The timing looked worse. Here's what makes a quasi-satellite different from a regular moon. True moons are gravitationally bound to their planet, trapped in stable orbits by the planet's mass. Quasi-satellites aren't bound at all. They orbit the Sun, not Earth, but their orbital period matches ours so closely that they appear to dance around us in the sky, keeping pace, staying nearby, never drifting too far away. It's a delicate balance, easily disrupted, rarely lasting more than a few centuries before gravitational perturbations from other planets knock the object into a different orbit. 2025 PN7 has been in this quasi-satellite configuration since the 1960s, not millions of years, not thousands of years, just since the space race, since Sputnik and Apollo and the frantic push to reach beyond our atmosphere before the other side did, since humanity started lobbing hardware into deep space on trajectories that would take them past other worlds, sometimes successfully, often not. Avi saw the orbital elements and asked a question nobody else wanted to touch. Is this thing natural, or did we make it? The paper he published with Adam Hibbert reads like a detective story written in orbital mechanics. They took every major interplanetary mission launched in the 1960s, pulled the departure dates and planetary arrival times, fed them into trajectory optimization software called OTS, and asked a simple question. Could any of these missions have ended up where 2025 PN7 is, now? One mission kept appearing in the results. Zonden launched by the Soviet Union on April 2nd. 1964 intended for Venus and almost immediately plagued by failures. The spacecraft lost attitude control, communications degraded, critical systems started dying one by one as it drifted through interplanetary space. Off course, underpowered, doomed. But here's the thing about rocket launches. They're not single objects. Every interplanetary mission consists of the probe itself. Sure, but also the upper stage that gave it the final push out of Earth orbit. For Zand 1, the upper stage was called Block L, a massive cylinder of metal and fuel tanks 3.2 m across, designed to fire once and then drift away as space junk. Except sometimes that junk doesn't drift. Sometimes it ends up in places that make you wonder. The trajectory analysis showed something remarkable. If you trace 2025 PN7 backward through time using the orbital elements we have now, it becomes a quasi-satellite of Earth right around 1964, the exact year Zond 1 launched. The heliocentric longitude of 2025 PN7 at Venus arrival dates matches Z1's trajectory with minimal deviation. Better than any other Venus mission from the era. Better than it should if this were just coincidence. The displacement calculations are even more interesting. When you compare where 2025 PN7 would have been during the Zond 1 flight versus where the Zod 1 probe itself was tracked, you get a minimum separation of about 8% of an astronomical unit in May 1964. That's roughly 12 million kilometers. Close, but not identical. Exactly the kind of separation you'd expect if the Block-L upper stage failed to deliver its full velocity boost to the probe, leaving both objects on similar but not identical trajectories toward Venus. And here's where it gets technical in a way that matters. Zonden performed a course correction burn on April 3, 1964, just one day after launch. Mid-course corrections are normal, sure, but they're usually planned well in advance based on precise tracking data. An emergency burn one day after launch suggests something went wrong during the initial boost phase. Something that required immediate correction, like for instance, the Block L stage failing to deliver the expected Delta V, leaving the probe short of the velocity it needed to reach Venus on schedule. If the Block L failed to perform its full burn, the probe would have ended up on a trajectory that fell short of Venus, which is exactly what seems to have happened. The official Soviet records for Zand 1 are sparse, classified for decades, but what information survives suggests the mission never achieved its intended trajectory. Contact was lost in May 1964 with the probe somewhere between Earth and Venus, off course, unable to correct drifting. Meanwhile, the block stage that pushed it would have continued on its own trajectory, shaped by whatever partial burn it managed before shutdown. No tracking, no interest. Just another piece of space debris in an era when nobody bothered cataloguing every fragment. It could have drifted for 60 years without anyone noticing, following an orbit that brought it back to Earth's neighbourhood just as we started getting good enough at detection to finally spot it. The brightness calculations support this scenario. If 2025 PN7 is a metallic cylinder 3.22 m wide, roughly the size of the Block L stage, with a highly reflective surface like you'd expect from 1960s Soviet engineering, the predicted magnitude matches what we observe. Not exactly. Orbital mechanics and albedo estimates always have uncertainty, but close enough that you can't rule it out based on brightness alone. The inclination fits. 2. When Zond 1 launched in April 1964, its orbital plane was tilted about 3.42 degrees 42 degrees relative to the ecliptic, the plane where most planets orbit. 2025 PN7 right now has an inclination of about 2.44 degrees. Different, but not incompatibly so. 60 years of gravitational perturbations from Jupiter, Venus, and Earth could easily account for that shift. In fact, it would be weirder if the inclination hadn't changed at all. So, we have a quasi-satellite that appeared in Earth's orbit in the 1960s, matches the trajectory of a failed Soviet Venus mission, has the right brightness for a block upper stage, shows the right inclination for that launch window, and sits in an orbit that requires almost no explanation beyond a simple rocket stage failure during the space race. Occam's razor says this is probably exactly what it looks like. We found our own trash. Except, and this is the part that keeps astronomers up at night, we can't be sure until we get spectroscopy. We need to analyse the light reflecting off 2025 PN7 to see what it's made of. Natural asteroids have distinct spectral signatures, minerals and rocks, and carbon compounds that form predictable absorption lines in reflected sunlight. Artificial objects made of aluminum, titanium, steel. They have different signatures. Metal reflects light differently than stone. You can tell them apart if you get a good spectrum. This has been done before. Back in September 2020, the Pan-STARRS telescope in Hawaii spotted an object designated 2020. So that looks suspicious. Similar situation. Quasi-satellite orbit appeared around Earth in the 1960s seemed too convenient to be natural. But in December 2020, NASA's Infrared Telescope facility got spectroscopy of 2020 and found stainless steel clear as day turned out to be the Centaur upper stage from NASA's Surveyor 2 mission to the Moon, launched in September 1966, tumbling through space for 54 years before we finally identified it. If 2025 PN7 is the Zond 1 block, spectroscopy will show metal, Soviet-era alloys, titanium and aluminum unmistakable. But if the spectrum shows silicates, carbonaceous compounds, asteroid minerals, then we're back to explaining how a natural object happened to become a quasi-satellite at exactly the moment humanity started exploring space. Possible, but suspicious. The paper explicitly calls for this test. Get a spectrum, measure the composition, confirm the origin. Simple enough request. You'd think. Major observatories have the capability. The object is bright enough to study magnitude 15, well in range of current instrumentation. So why hasn't anyone published spectroscopy yet? Why are we 3 months past the discovery with no confirmation either way? Maybe it's queue time. Telescope schedules book up months in advance. Maybe it's weather. Maybe it's priorities with 3i Atlas eating up observation resources. Or maybe, and this is purely speculation, maybe someone already got spectroscopy and didn't like what they found. Because here's the uncomfortable question underneath all of this. If 2025 PN7 is natural, we need to explain the coincidence. Quasi-satellite orbits are rare. Quasi-satellite captures that happen during the exact decade when humanity launches its first interplanetary missions are rarer. Still, natural objects don't care about our schedule. They don't wait for us to start exploring before they show up. So, either we got cosmically lucky, finding a natural quasi-satellite that happened to arrive during the space race, or the object is exactly what it looks like, and we're just spooked by our own reflection. But if it's artificial, if spectroscopy confirms metal, we need to explain why a failed Soviet rocket stage ended up in such a perfect quasi-satellite orbit, and that requires either extraordinary luck, the Block L failing in exactly the right way to capture into resonance, or extraordinary engineering. The Soviets intentionally designing the upper stage to end up there. Neither explanation is satisfying. One requires too much coincidence. The other requires too much foresight for 1964 technology. There's a third option nobody wants to say out loud. What if it's not ours at all? What if 2025 PN7 is older than the 1960s? Older than human spaceflight? Sitting in quasi-satellite orbit for decades or centuries before we noticed. And the timing is just when we finally got telescopes good enough to spot it. What if the reason it matches the Zond 1 trajectory so well is because something else was already there, already watching, and we sent Zand 1 straight toward it without realizing? Low hints at this in the discussion section. He mentions that 2 out of 3 interstellar visitors so far, 1i Umamu and 3i Atlas, appear anomalous in ways that challenge natural explanations. He points out that if we're seeing artificial interstellar objects at this rate with our primitive detection capabilities, the implication is that such objects are common, way more common than natural interstellar asteroids. Which means space is full of probes, monitors, scouts, whatever you want to call them, drifting between stars, checking in on promising systems, cataloguing worlds where life might emerge. And if that's true, if the galaxy is saturated with ancient technology wandering from star to star, then finding one in quasi-satellite orbit around Earth isn't suspicious at all. It's expected. It would be weird if there weren't something keeping watch on the one planet in this system that developed industrial civilization. We're interesting now. We weren't interesting a million years ago. But put a probe in long-term orbit and wait. Sooner or later, if the planet's in the habitable zone, if it has water and oxygen and the right chemistry, something might wake up down there. Better keep an eye on it. That's the scenario that makes 2025 PN7 really uncomfortable. Not because it's definitely alien. We don't have that evidence. But because if we can't confirm it's ours, if spectroscopy comes back showing materials or construction that don't match 1960s Soviet engineering, we're left with an object in Earth orbit that predates our space program, sits in a position perfect for long-term observation, and activated or became detectable right as we started seriously looking for interstellar visitors. The timing connects to 3 Atlas in a way that feels like pattern, even if it isn't proof. Both objects entered our awareness in 2025. Both challenge simple natural explanations. Both sit in orbits that would make perfect sense for reconnaissance missions. 322 Atlas on a flyby trajectory that brings it close to Venus, Mars, and Jupiter before leaving the system. 2025 PN7 in a stable quasi-satellite position where it can watch Earth indefinitely without requiring course corrections. If you are designing a 2-stage survey mission, this is exactly how you do it. Fast probe for the outer planets and inner system flyby. Slow monitor for the habitable world. Leave the monitor in place while the fast probe reports back. Pure speculation. Sure. But the numbers keep lining up in ways that make you wonder. The Zond 1 connection provides perfect cover. If anyone notices the quasi-satellite blamed on Cold War space junk, nobody checks too carefully. Nobody demands spectroscopy. It's just our trash. Embarrassing but harmless. Case closed. Until someone like Lowe decides to actually run the calculations and discovers that the trash explanation, while plausible, requires a very specific sequence of failures that happen to produce a very useful orbit. We should know soon. Spectroscopy will settle this. Metal means human. Silicate means natural. Anything else means we have a problem. But until those results come in, until someone publishes a spectrum showing clear identification one way or another, 2025 PN7 sits in Earth orbit watching, waiting, being exactly ambiguous enough that both explanations stay on the table. And if you're wondering why this story isn't getting more attention, why major media outlets aren't screaming about Earth's potential new moon, consider what happens if it turns out to be alien. Consider the panic. Consider the questions. If there's something watching us from orbit right now, how long has it been there? What has it seen? What is it reporting back to? Those aren't comfortable questions. Much easier to assume it's Soviet space junk and move on. But tomorrow morning, when 3T reaches perihelion, when every telescope points toward that interstellar visitor, and we finally get to watch what happens at closest approach, remember that we might not be the only ones watching. If 2025 PN7 is what the uncomfortable scenarios suggest, it has a front row seat, perfect vantage point, uninterrupted view, and whatever data it collects, whatever observations it makes, they won't be ours to analyse. Las Vegas gets eyes in the sky. Sometimes the most important scientific announcements don't come through press releases or academic journals. Sometimes they come on podcasts at 2 a.m, slipped into a conversation between a physicist and a comedian, mentioned almost casually, like, "It's no big deal that we just installed what might be the most sophisticated anomaly detection system on the planet on top of a $2.3 billion entertainment venue in the middle of the Nevada desert." October 24th, 2025 Avi Lobo appears on the Joe Rogan Experience and drops a detail that barely registered in the headlines, but should terrify anyone who understands what it means. The Galileo Project, his initiative to search for evidence of extraterrestrial technology using scientific methods, Rather than anecdotes and speculation, just completed installation of an all-sky camera array on top of Sphere in Las Vegas. Not near Sphere, not next to Sphere, on top of it, at the highest point above the LED displays, positioned like a freckle on the perfect outer skin of the world's largest and most expensive immersive entertainment facility. Let's talk about what Sphere actually is, because context matters. This isn't some random building lowicked for telescope access. Sphere is a statement, a monument to excess and ambition. Built at a cost that could fund a medium-sized space mission, 112 m high, 157 m wide, a perfect hemisphere covered in 54,000 m of LED displays, making it the largest screen on Earth. Inside, 17,600 seats, immersive audio systems with beamforming and wavefield synthesis, haptic feedback built into the chairs so you can feel the content vibrating through your body. It opened in September 2023 with a U2 concert series and has since hosted everything from corporate events to experimental films rendered at resolutions that make IMAX look quaint. And now, sitting on top of all that spectacle, invisible to the crowds, gawking at the exterior displays, there's an array of cameras pointed at the sky, recording everything that moves, tracking everything anomalous, feeding data into machine learning algorithms designed to separate drones from birds from airplanes, from satellites from things that don't fit any category. Lowe describes the installation like it's a perfectly natural thing to do. His team, led by Ezra Kelderman, Alex Delacroix, Lily Kwan, and Eric Mason, spent weeks hauling equipment to the roof, mounting camera arrays in both infrared and visible wavelengths, calibrating sensors, testing tracking algorithms. He talks about climbing to the top during installation, looking out over Las Vegas from a vantage point few people ever see, and telling his team, if you can make it to the top of Sphere, you'll make it anywhere. Cute line, but the subtext is what matters. Why Sphere? Why now? Why Las Vegas? The official explanation makes sense on the surface. Sphere provides height, giving the cameras an unobstructed view of a huge volume of airspace. Las Vegas has clear skies most of the year, minimal cloud cover, perfect for optical observation. The city sits in a desert valley surrounded by restricted military airspace, including Nellis Air Force Base and the Nevada Test and Training Range, areas known for experimental aircraft testing, and if you believe the folklore, occasional sightings of things that move in ways conventional aircraft shouldn't. If you're looking for anomalies, Las Vegas is ground zero. But there's another reason nobody says out loud. Sphere belongs to Madison Square Garden Entertainment, run by Jim Dolan as executive chairman and CEO. When Dolan and Jane Rosenthal, CEO of Tribeca Enterprises, showed up at Loeb's door in September 2024 with an offer to build a Galileo Project observatory on top of their $2.3 billion venue. They weren't just offering telescope space. They were offering legitimacy, cover, institutional backing from entities with deep pockets and mainstream credibility. You can call Lowe a fringe scientist all you want, accuse him of chasing aliens for publicity, dismiss his theories as academic attention-seeking. Much harder to do that when major entertainment corporations are funding his research and giving him access to premium real estate for his instruments. The Sphere installation isn't just one observatory, it's 3. The main array sits on top of Sphere itself. Highest point, best vantage. But the Galileo team also installed 2 other identical copies of the system located 10 kilometers away, positioned at the 2 corners of the base of a triangle. 3 observatories, 3 different viewing angles, same volume of sky. This is called triangulation, and it's the only way to get accurate 3-dimensional tracking of objects in the air. With one camera, you can see something moving, but you can't tell how far away it is. Distant slow object looks the same as close fast object. You need multiple viewpoints separated by known distances observing the same target simultaneously. Then you can calculate actual position, actual velocity, actual acceleration. The geometry gives you truth. So when the Galileo project talks about detecting unidentified anomalous phenomena over Las Vegas, they're not just spotting lights in the sky and guessing. They're getting precise measurements, position accurate to meters, velocity vectors with directional components, acceleration profiles showing whether an object is under power or coasting. And most importantly, they're filtering out everything mundane. Drones have characteristic flight patterns, limited speed ranges, predictable altitude caps. Helicopters show up on transponders and move in ways constrained by rotor physics. Airplanes follow approach corridors and FAA regulations. Satellites pass overhead in predictable orbits with known timing. Birds fly like birds. Insects swarm like insects. Balloons drift with the wind. The machine learning algorithms know all of this. They've been trained on millions of examples of ordinary objects doing ordinary things. When something moves outside those performance envelopes, when acceleration exceeds what human-made propulsion can deliver, when objects make 90-degree turns at speeds that would pulverize any physical structure, when things hover motionless for extended periods with no visible means of support, the system flags it. Not as proof of extraterrestrial technology, not yet, but as genuinely anomalous, something worth investigating further. The LO estimates the system will analyze data on a few million objects per year. Most will be mundane: commercial jets, private planes, drones, satellites, the endless traffic of a sky above a major city. But statistical anomalies exist. Outliers happen, and in those outliers, buried in terabytes of positional data and spectral analysis, might be the first unambiguous evidence that we're not the only technological civilization currently operating in near-Earth space. The timing of the announcement matters as much as the content. October 24th, 5 days before 3I Atlas reaches Perihalen, 4 days after amateur astronomers proved the object would be visible during its closest approach, 3 days before institutional protocols finish falling into place, Lowe goes on the world's biggest podcast and casually mentions that he just installed the most sophisticated UAP detection system ever built, capable of tracking anomalies over one of the busiest and most watched cities in America. Right. As an interstellar visitor swings through our inner solar system, exhibiting behavior that challenges natural explanations. You could call that coincidence. You could also call it preparation. If 3 Atlas does something unusual tomorrow, if course corrections happen or smaller objects deploy or any of the technological scenarios play out, Las Vegas will be watching. The Sphere Array will record it, and unlike government installations with classified protocols and restricted data access, the Galileo project operates in the open. Academic transparency, published results, data available for independent verification. Whatever they see will know about it. There's something almost poetic about using Sphere for this purpose. The building was designed for spectacle, for overwhelming the senses with light and sound and carefully choreographed illusion. Inside, you can watch anything the producers want you to see. Outside, covered in the world's largest video screen, Sphere can project any image, any message, any reality that operators choose, but on top, hidden from the crowds, immune to the spectacle, scientific instruments point at the actual sky, recording actual events, measuring actual physics, truth hiding above illusion, reality sitting on top of fantasy. The Loeb talked about another detail during the podcast that deserves attention. Tomorrow, October 25th, he's attending a NASCAR race at Kevin Harvick's Speedway in Bakersfield, California, where driver Alex Malik is racing a car featuring the Galileo Project logo, 3I Atlas imagery, and Lowe's face printed on the vehicle. Full branding, mainstream exposure, racing culture meets astrophysics. And according to Lowe, he might get the chance to drive the car himself during practice sessions, helmet and suit and all, physicist turned race car driver for an afternoon. On the surface, this looks like outreach, public engagement, making science accessible. But there's strategy here too. When you put your research on a NASCAR vehicle, when you show up at tracks and sign autographs and talk to fans who might never read an academic paper. You're building a constituency. People who care about the work, people who will demand answers if data gets suppressed, or findings get classified, or institutions try to bury results that challenge comfortable assumptions. You're creating pressure from below grassroots interest that's harder to ignore than purely academic curiosity. The Sphere Observatory represents the same strategy scaled up. It's public science, funded by private entities, operating in plain sight, impossible to classify without explaining why classified observation of Las Vegas airspace suddenly became a national security priority. If the Galileo project detects something genuinely anomalous over Nevada, something that moves beyond human technological capabilities, that data will be public, published, analysed by independent researchers. You can't retroactively classify it without admitting that unclassified observation stumbled onto something you've been keeping secret. This is exactly the kind of pressure that forces disclosure, not dramatic whistleblowers making unverifiable claims, not leaked documents with suspicious provenance. Just good instruments, good data, good analysis, and public access. If it's real, if objects in our airspace demonstrate technological capabilities beyond what we can build, multiple independent observation networks will eventually catch them on camera, triangulated, measured, undeniable. And when that happens, when the evidence becomes overwhelming, secrecy becomes impossible. We're already seeing hints of what that pressure looks like. Congressional hearings on UAP sightings have intensified over the past 2 years. Military personnel are coming forward with testimony about objects that violated restricted airspace and demonstrated performance characteristics that don't match any known aircraft. Pentagon officials are being grilled about lack of transparency. The All-Domain Anomaly Resolution Office exists now specifically to investigate these reports, even if their conclusions remain frustratingly vague and their funding remains questionable. But AARO operates within the classified world. They can investigate. Sure, but their findings can be locked behind security protocols, redacted, withheld from public analysis. The Galileo project doesn't have that limitation. When they detect something, when their cameras track an object performing maneuvers that challenge physics as we understand it, that information goes straight to peer review, published papers, open data repositories. Anyone with the expertise can verify the analysis, check the math, confirm or refute the conclusions. That's the real threat to secrecy. Not hackers or leakers, just good science operating in daylight, impossible to suppress without revealing that suppression is happening. What happens tomorrow morning becomes more interesting in this context. 3E Atlas reaches perihelion at 11:36 Universal Time. Multiple observatories around the world will be watching, weather permitting. Amateur astronomers with backyard telescopes, professional facilities with research-grade instruments, space-based assets like the James Webb Telescope and Hubble, and the European Space Agency missions. All of them recording data, all of them noting what happens, and now sitting on top of Sphere in Las Vegas. The Galileo Project Array will be watching too. Not the interstellar object itself that's too far away for ground-based optical tracking in daylight, but the Ski Nevada, the space where objects might appear if something deploys from 3E Atlas. The volume where probes would become detectable if they use the sun's gravitational assist to redirect toward inner system targets. If mini-probes launch tomorrow, if the mothership hypothesis plays out and 3E Atlas releases smaller craft during perihelion passage, some of those objects might head toward Earth. Reverse Abeth maneuvers using thrust at perihelion to slow down and drop into bound orbits, and when they arrive, weeks or months from now, they'll pass over cities, over deserts, over Las Vegas, where cameras will be waiting. One final detail from the podcast matters. Lowe mentioned that the NASCAR race he's attending tomorrow happens the same day as perihelion, October 29th, morning astronomical event, afternoon racing event, physicist at the track while history potentially unfolds 200 million kilometers away. There's symbolism in that. Speed and precision, risk and observation, human engineering at its limits right as we potentially witness engineering from beyond those limits. What happens in Vegas usually stays in Vegas. Or so the saying goes, but what happens over Vegas, recorded by scientific instruments, analysed by machine learning, verified by triangulation, that won't stay anywhere. That goes into the permanent record, that becomes data we can't ignore, 8 impossible things. And let's talk about what we actually know. Stripped of speculation and hypothesis, just the documented observations that don't fit comfortable explanations. Avi ranks through our atlas at 4 out of 10 on his scale for potential technological origin. Not definitive, not proof, but significant enough that dismissing the possibility requires ignoring multiple independent anomalies that compound in ways natural scenarios struggle to explain. 8 specific observations earned that ranking. Each one individually could have mundane explanations. Together, they form a pattern that looks less like coincidence and more like design. Anomaly 1, trajectory alignment, 3Z Atlas approaches the inner solar system on a path tilted just 5 degrees relative to the ecliptic plane. That flat disk where all major planets orbit. For objects arriving from random directions in interstellar space are distributed esotropically across the celestial sphere, the probability of happening to align this closely with our planetary plane is about 0.2%, 1 in 500, low odds, but not impossible. Systems eject debris in all directions. Most of it misses other systems entirely, but occasionally, rarely, something launched from another star happens to arrive aligned with the target system's orbital plane through pure chance. Or you could design the trajectory that way deliberately. If you're sending a probe to survey planets, you aim for the ecliptic. Everything interesting orbits there. You don't waste Delta V approaching from above or below the plane where targets are sparse. You come in shallow, aligned with planetary orbits, maximizing encounter opportunities with minimal course correction. That's basic mission planning for any interstellar survey craft. The alignment alone doesn't prove anything, but it's the first data point. Keep it in mind. Anomaly 2 planetary encounters. 3 Atlas passes unusually close to 3 different planets during its journey through our system. Venus within tens of millions of kilometers. Mars even closer, about 30 million kilometers on October 3rd. Jupiter within 54 million kilometers next March. The probability of a random interstellar trajectory bringing an object this close to 3 separate planets is extraordinarily low. You're combining the probability of entering the solar system at all times, the probability of trajectory alignment that brings you near the inner planets, times the probability of timing your arrival, so planetary positions line up for multiple encounters. Lowe's calculation puts the combined probability under 0.005%, 1 in 20,000 possible technically, but requiring very specific initial conditions that look suspiciously like targeting. If you're designing a grand tour mission to survey multiple worlds in one pass, this is roughly the trajectory you'd pick. Fast flyby of the inner system with Venus and Mars close approaches, gravity assist from Jupiter on the way out to boost velocity and adjust departure angle. Efficient, thorough, exactly what NASA's Voyager missions did in our outer system back in the 70s. Natural objects don't target anything. They follow whatever trajectory they acquired during ejection from their parent system. Shaped by close encounters with planets or stars during their interstellar journey, arriving at our sun from essentially random directions with essentially random speeds, that most of them miss planets entirely is unsurprising. Space is enormous. Planets are tiny. Hitting multiple targets requires either incredible luck or deliberate planning. 3 Atlas hits multiple targets. Anomaly 3 solar conjunction timing. Perihelion at 1. 356 astronomical units happens to occur during the same period when the object reaches minimal angular separation from the Sun as viewed from Earth. We've discussed this already. The mainstream explanation said solar conjunction would make observation impossible during the critical window when any spacecraft would perform oath maneuvers. Except amateur observations proved that explanation wrong. The object is visible, but the narrative itself is revealing. Why tell us it would be hidden unless someone wanted to discourage looking? The probability of perihelion and solar conjunction Aligning this closely assuming random trajectory is about 7% according to the calculations. Not spectacularly unlikely, but add it to the other probabilities. Ecliptic alignment times, planetary encounters, times solar conjunction timing. The compound probability drops into statistical improbability. Any one of these could be chance. All three together start looking deliberate. Anomaly 4, the anti-tail phenomenon. From July through September, 3E Atlas exhibited something extremely rare. An anti-tail material ejected toward the sun rather than away from it. This violates the basic physics of how solar wind and radiation pressure work. Comet tails should always point away from the sun, pushed by the stream of charged particles and photons flowing outward. Tails toward the sun require a very specific geometry where dust particles on highly elliptical orbits appear projected ahead of the nucleus or active propulsion overcoming solar wind. Low and his colleague Eric Cato published a detailed model explaining the transition from anti-tail to regular tail in September as 3I Atlas approached perihelion. Their physics is solid. Temperature-driven sublimation rates change with distance. Ice particles have different lifetimes depending on size and composition. The scattering cross-section peaks at certain distances where volatile survival times produce maximum optical effect. All perfectly natural processes that can produce anti-tail appearance under the right conditions. But Adam Hibbard, working with Low on trajectory analysis, pointed out something interesting. If 3E Atlas were an alien spacecraft slowing down and the anti-tail represented braking thrust, then the transition to a regular tail would mark the end of deceleration. Thrust turns off. Outgassing takes over. Behavior shifts from powered flight to passive coasting. The timing fits, the physics fits, and while natural explanations work, so does the technological one. Ambiguity rather than resolution. Anomaly 5. Nickel emissions without iron. Spectroscopy of 3L coma. The cloud of gas and dust surrounding the nucleus. Detected glowing nickel vapor. This is unusual. Comets contain metals, sure, but usually as silicate minerals or metallic grains embedded in ice, not as vapor. Getting nickel into the gas phase requires very high temperatures, either from solar heating of a surface rich in volatile nickel compounds, or from internal processes that vaporize metal. And the really strange part is the absence of corresponding iron signatures. Nickel and iron occur together in meteorites, in asteroids, in pretty much every natural solar system object we've studied. Finding one without the other suggests either very unusual composition or selective emission. Spacecraft hulls use nickel alloys. Stainless steel contains nickel. Batteries and electronic components incorporate nickel. If you were building an interstellar probe, nickel would be part of the structural materials and could volatilize if exposed to intense solar heating. Not proof of artificial origin, but consistent with it in ways that make natural explanations more complicated. Anomaly 6 carbon dioxide dominance. The James Webb Space Telescope measured 3-2 Atlas composition in August and found an extreme carbon dioxide to water ice ratio of 8:1, highest ever recorded for any comet. Most solar system comets are water-rich with carbon dioxide as a minor component. The reverse ratio suggests formation in a very cold environment, farther from the parent star than our Kuiper belt, where carbon dioxide ices are more stable than water ice. Or it suggests deliberate storage of volatiles chosen for properties that make them useful. Carbon dioxide is an excellent refrigerant. It sublimates cleanly without leaving residue. It's dense, easy to store, and releases energy predictably when heated. If you're designing a comet camouflage for a spacecraft, high carbon dioxide content gives you the optical signature you need while minimizing water production that would be hard to control. Again, natural formation in an ultra-cold birth environment explains this, but so does engineering. 7 early activation. The Transing Exoplanet Survey Satellite TEAS detected outgassing activity from 3AT as early as May 7th. 2025, when the object was approximately 6.4 astronomical units from the Sun. That's farther out than Jupiter. Normal comets don't become active until they're much closer, typically inside 3 astronomical units, where solar heating becomes intense enough to drive significant sublimation. Early activation suggests extremely volatile ices, materials that sublimate at very low temperatures, consistent with formation in the coldest regions of a planetary system or with deliberate design to begin gas emission early for visibility. You want people to detect your probe? You make it visible from far away. Carbon dioxide activity at 6 astronomical units does exactly that. Flags the object as interesting, gets telescopes pointed in your direction, ensures tracking throughout the entire approach phase. Very convenient if you're trying to guarantee observation. Anomaly 8 geometric emission patterns. Multiple telescope observations noted that the coma structure showed patterns inconsistent with random, chaotic outgassing from a rotating irregular nucleus. Brightness distributions appeared more organized, potentially symmetric in ways that suggest directed jets or controlled emission, rather than uncontrolled sublimation driven purely by solar heating. This is the weakest of the 8 anomalies because coma morphology is complex and influenced by rotation, composition, dust grain sizes, all factors that can produce apparent geometry without requiring intelligence. But combined with everything else, it adds to the weight of evidence that something about this object behaves differently than natural interstellar comets should. 4 out of 10 on the Loeb scale. Not alien confirmed, not even alien probable. Just anomalous enough in enough independent ways that the technological hypothesis deserves serious consideration rather than immediate dismissal. The counter-arguments are important, too. Most astronomers who've studied 3 Atlas conclude it's natural. Spectroscopy shows volatile ices, morphology shows comet-like features, the trajectory, while statistically unusual, isn't impossible for natural ejection and subsequent interstellar journey. Every individual anomaly has at least one natural explanation. Even if those explanations require specific conditions or unlikely combinations of factors, the anti-tail is rare, but occurs in natural comets under geometric circumstances. The carbon dioxide dominance is unusual but consistent with formation in cold environments. The nickel without iron could reflect specific mineral composition or fractionation processes during ejection. Early outgassing happens with super volatile ices like carbon monoxide that sublimate far from the sun. Science requires parity. When faced with observations that could be explained either by well-understood natural processes or by speculative technological scenarios, you default to natural unless the evidence becomes overwhelming. We're not overwhelming yet. We're at interesting, worthy of investigation, demanding better data before conclusions. But here's what makes the situation genuinely uncertain. The null hypothesis, the assumption that 3 Atlas is natural unless proven otherwise, rests on the belief that technological interstellar probes are so rare that we can safely ignore that possibility when interpreting observations. If probes don't exist, if no civilization has ever successfully sent hardware between stars, then any interstellar visitor must be natural because nothing else is on the table. But if probes do exist, if even one advanced civilization in the galaxy has succeeded at interstellar exploration and deployed survey craft to catalogue promising systems, then the prior probability changes. Suddenly, the technological hypothesis isn't wildly improbable speculation. It's a legitimate alternative explanation that might actually be more likely than natural arrival, given the statistical improbability of random trajectories producing all 8 observed anomalies simultaneously. This is the core disagreement between LOE and the majority of astronomers, not about the data. Everyone sees the same observations, the same spectroscopy, the same trajectory calculations. The disagreement is about what we assume is possible before we look at the evidence. If you assume aliens are vanishingly rare or non-existent, 3 Atlas must be natural despite the anomalies. If you assume technological civilizations are common enough that probes might occasionally visit, 3T might be artificial despite showing comet-like features. We can't resolve that disagreement with philosophical arguments. We need more data, better observations, measurements that distinguish between the scenarios so clearly that interpretation becomes unambiguous. Tomorrow's perihelion passage is exactly that kind of measurement opportunity. Natural comets behave predictably at close solar approach. Brightness increases according to inverse square law modified by sublimation rates. Trajectory follows gravitational predictions modified slightly by outgassing rocket effects. Coma expands symmetrically driven by uniform heating. No surprises, no deviations beyond what physics allows for passive objects. Artificial probes have options, natural objects don't. They can maneuver, they can deploy secondary craft, they can modulate brightness by controlling emission, they can time activities to maximize efficiency or minimize detection. If 3E Atlas is technological, perihelion's when that becomes testable. The object either does things comets can't do or it doesn't. The beauty of this situation is that we don't need to convince anyone of anything beforehand. We just need to watch and measure. If tomorrow brings conventional comet behavior, the technological hypothesis weakens dramatically. Sure, you could argue the probe is deliberately mimicking natural behavior to avoid detection, but at that point, you're invoking conspiracies to save hypothesis. And science doesn't work that way. If it looks like a comet, acts like a comet, and shows no sign of capability beyond what comets can do naturally, the simplest explanation is that it's a comet. But if tomorrow brings something unexpected, if any of the 8 anomalies intensifies or new ones appear, if 3 Atlas does anything that requires technological capability to explain, then the conversation shifts immediately, not to proof, necessarily, but to serious scientific investigation of the possibility that we're watching artificial hardware transit our solar system. That investigation would involve dedicated tracking missions, interception attempts if feasible, intensive spectroscopy searching for industrial signatures, radio monitoring for communication signals, everything we can throw at the problem to confirm or refute artificial origin. That's what's at stake tomorrow. Not public disclosure or government announcement or any of the dramatic scenarios that conspiracy theories love, just data measurements that either support natural explanation and let us move on, or challenge natural explanation and demand deeper investigation. Either outcome advances our understanding. Either way, we learn something important about what travels between stars and how common that travel might be. Either we confirm that interstellar space is mostly empty with occasional natural debris ejected from other systems drifting through the dark, or we discover that the galaxy is full of emissaries from civilizations we haven't met yet. Machines designed to catalogue worlds and report back to makers we can barely imagine. The data decides not our hopes, not our fears, not our philosophical preferences about whether we're alone, just the cold, perfect logic of measurement telling us what happened when an object from another star swung past ours at the closest approach. Physics and trajectory allowed, silent soldiers, while astronomers debate whether 3E Atlas is natural or designed. Another story runs parallel, equally strange, equally uncomfortable. Military personnel are coming forward with testimony about objects in our airspace that shouldn't exist. Experienced pilots, radar operators, intelligence specialists, people with security clearances and decorated careers, risking everything to say publicly what they saw and facing consequences that suggest someone really doesn't want this conversation happening. September 9th, 2025, the House Oversight and Government Reform Task Force on the Declassification of Federal Secrets holds a hearing titled Restoring Public Trust Through UAP Transparency and Whistleblower Protection. Not a fringe event, not a conspiracy convention. Official congressional hearing with sworn testimony. Public record covered by mainstream media. And the stories that emerged should have dominated news cycles for weeks, but instead got buried under coverage of election campaigns and international conflicts and celebrity scandals. Air Force veteran Dylan Boland testified about an incident at Langley Air Force Base in Virginia back in 2012. He was working overnight as a geospatial intelligence specialist, trained observer, someone whose job required accurate identification of aircraft and assessment of capabilities. Stepped outside for a cigarette break, Standard procedure. Nothing unusual, just a few minutes to clear his head during a long shift. And then a triangular craft appeared directly overhead. Silent, hovering, motionless in a way that helicopters can't maintain. Stable in a way that requires either incredible pilot skill or technology that doesn't rely on rotors or thrust vectoring for lift. He watched it for several minutes, close enough to see details, near enough that if it were conventional aircraft, he'd have heard engines, felt rotor wash, noticed navigation lights and standard aviation markings. Nothing. Just geometric perfection hanging in the night sky above a secure military installation. Observing or being observed, present in a way that felt deliberate. He reported it through proper channels, filed the required paperwork, described what he saw in technical language that left no room for misinterpretation. And then things got complicated. Interview with the All-Domain Anomaly Resolution Office, ARO, in 2023, more than a decade after the incident. Questions about details, timing, whether he could have been mistaken, whether conventional explanations fit the observation. He answered everything honestly, provided additional context, stood by his report, and then ARO dismissed his claims, not as unverifiable, not as ambiguous. Dismissed. Assessment concluded that his testimony didn't support the reported sighting, as if telling someone their memory is wrong makes the memory disappear. But dismissal was just the start. According to Borland's testimony, he faced reputational damage, workplace retaliation, manipulation of his security clearance status in ways that made continued employment in intelligence fields difficult, blacklisting from federal agencies he'd previously worked with successfully, career derailment because he reported something unusual through the channels he was supposed to use for exactly that purpose. Think about the incentive structure that creates your military personnel. You see something that doesn't match known aircraft profiles. You have two choices. Report it and risk career destruction, or stay silent and hope someone else deals with it. Most people choose silence. It's safer. It's easier. It doesn't paint a target on your professional life, which means most sightings never get reported at all. And the ones that do come from people brave enough or angry enough or principled enough to accept the consequences. Borland wasn't the only whistleblower that day. Representative Eric Burles from Missouri, task force member, played video footage during the hearing that he said showed an MQ-9 Reaper drone striking an unidentified orb off the coast of Yemen in October 2024. Classified footage leaked somehow, making its way to congressional oversight despite Pentagon preferences. The video quality is poor, typical of military sensor feeds converted and compressed for storage. But the key details are visible. Fast-moving object, spherical or nearly so, drone launches Hellfire missile. Missile strikes target dead center, clean hit, and the object keeps flying. No explosion, no fragmentation, no debris field, just continued flight on roughly the same trajectory as before impact. As if a missile designed to destroy armoured vehicles and fortified structures had hit nothing more substantial than weather balloon. Except weather balloons don't maintain course after explosive impact. They rupture, deflate, tumble. This thing flew on. Burles' question to Pentagon representatives was simple. Why are we being blocked from this information? If it's a balloon, say it's a balloon and release the analysis. If it's adversary technology, brief Congress in classified session with actual evidence and threat assessment. If it's something else, something that can absorb kinetic impact from military ordnance without visible damage. That seems like information the public and elected officials should have access to. Instead, silence. Deflection. Claims that releasing more information would compromise sources and methods. Sources and methods for what observing objects in our airspace. That's what radar and optical sensors do by design. Unless the concern is that releasing footage would reveal capabilities we don't want adversaries knowing about, or worse, reveal that we've been observing objects with capabilities we can't explain for longer than we've admitted, and classification is the only thing preventing difficult questions about why we didn't tell anyone. The Yemen incident adds to a growing collection of similar cases. The Nimitz encounters off San Diego in 2004, where Navy pilots tracked objects performing maneuvers that violated known aerodynamics. The gimbal video from 2015 showing rotation and flight characteristics inconsistent with conventional aircraft or drones. The Tic Tac incident, where objects descended from high altitude to sea level in seconds, accelerating at rates that would liquefy human pilots. All officially acknowledged now, all released through Freedom of Information requests or leaks, all previously classified with explanations that don't satisfy basic physics. Questions about how these objects moved the way they moved. Representative Jasmine Crockett from Texas proposed during the hearing that many UAP sightings might be adversary technology. China and Russia developing capabilities that exceed American performance envelopes. Hypersonic drones, advanced stealth systems, electronic warfare platforms that spoof sensors and create false readings. Perfectly reasonable hypothesis. If our adversaries have technology we don't understand yet, seeing it in operation would produce exactly these kinds of baffling observations. Military pilots encountering next-generation hardware and reporting it as anomalous because it exceeds current understanding. But that hypothesis requires that adversaries have technology significantly more advanced than ours, operating regularly in American airspace without challenge or response. That's either terrifying incompetence on the part of our defense systems or terrifying capability on the part of our adversaries. Either way, it deserves congressional attention and public awareness rather than classification and dismissal, unless it's not adversary technology, unless the objects performing impossible maneuvers aren't human at all, from any nation belonging to any terrestrial military, then classification makes a different kind of sense, not protecting sources and methods, protecting something more fundamental, the narrative that we understand what flies in our skies, the assumption that Earth's airspace is under human control and everything in it has human origin, the comfortable belief that if something looks advanced, we, or someone like us, built it. The Old Domain Anomaly Resolution Office was established specifically to investigate UAP reports systematically, applying scientific rigor, collecting data from multiple sensor platforms, analyzing incidents to determine origins and capabilities. Good mandate, necessary mission. But the office's public statements consistently emphasize that they found no verifiable evidence of extraterrestrial activity or technology. No proof that any of the thousands of reported sightings represent non-human intelligence, which could mean exactly what it says. Years of investigation, thousands of reports analysed, and nothing definitively alien found. The sightings are all misidentifications, sensor errors, adversary technology, experimental aircraft, atmospheric phenomena, or honest mistakes by trained observers under stressful conditions. Case closed. We're alone. Mystery solved. Or it could mean that a way operating within the classified world isn't free to discuss findings that would challenge fundamental assumptions about human technological dominance. If they have recovered materials, tracked objects, analysed data that points towards non-human origin, releasing that information requires approvals that might never come. Meanwhile, whistleblowers who saw the same things and didn't have classification constraints face retaliation for speaking publicly about experiences they're not supposed to share. The pattern is consistent across multiple cases. Experienced observer reports anomalous event. Official investigation concludes insufficient evidence or conventional explanation. Observer faces career consequences if they persist in claiming the event was genuinely unusual. Media coverage is minimal. Public interest fades. Incident gets filed away as another unsolved case in a database nobody outside security clearances can access fully. But the cases accumulate. Individual reports might be ambiguous. Collective weight becomes harder to dismiss when you have dozens of trained military personnel across different branches. Different decades, different locations, reporting similar phenomena, objects that move in ways that challenge physics, craft that show no visible means of propulsion, encounters that get classified, immediately investigated behind closed doors. You start seeing pattern. David Grush, former intelligence official, testified before Congress in July 2023 that the United States government has been running secret UFO retrieval programs for decades, recovering crashed or landed craft, analysing materials, reverse engineering technology programs so classified that even congressional oversight committees weren't briefed. Black budget operations funded through mechanisms that hide expenditure from normal fiscal accountability. His testimony was explosive. His credentials were legitimate, and the response from official channels was complete denial. No such programs exist. Never have. Grush is mistaken or misled or lying. Pick whichever explanation lets you sleep at night, except other whistleblowers came forward afterwards supporting Grush's claims, not with physical evidence. Most of that is locked behind security protocols they can't legally bypass, but with corroboration, confirming that programs with those characteristics existed in their experience. That materials were studied in facilities they had access to. That crash retrievals happened and got covered up under legitimate classified aircraft recovery operations. Enough supporting testimony that dismissing all of it as coordinated delusion or deliberate disinformation becomes the conspiracy theory, which brings us back to transparency. If the government has nothing to hide, if UAP are all explainable through conventional means, releasing data should be trivial. Publish the sensor readings, declassify the footage, let independent scientists analyse the evidence and reach conclusions based on physics rather than institutional preference. Transparency would end speculation immediately. Either the data supports extraordinary claims or it doesn't. Let the data speak, but transparency doesn't happen. Information stays classified. Whistleblowers face retaliation. Congressional requests for briefing get stonewalled or delayed or given partial answers that raise more questions than they resolve. And the public is left trying to assemble coherent pictures from fragments, leaks, testimony from people brave enough to risk everything to say what they saw. The National Archives established Record Group 615 in response to the 2024 National Defense Authorization Act, the Unidentified Anomalous Phenomena Records Collection. Federal agencies are required to review, identify, and organize every UAP record in their custody for disclosure to the public. Deadline is September 30th, 2025 tomorrow, as 3 Atlas reaches perihelion, as we potentially watch an interstellar visitor perform maneuvers that might confirm technological origin. The institutional deadline for UAP disclosure also arrives. Timing that's either perfect cosmic irony or deliberately coordinated to coincide pressure from multiple directions. But deadlines mean nothing without enforcement. Agencies can claim they're complying while releasing heavily redacted documents or withholding entire categories of records under national security exemptions, without independent verification, without consequences for non-compliance. Deadline announcements are just public relations. Show of transparency without substance. Christopher Mellon, former Deputy Assistant Secretary of Defense for Intelligence, has been pushing for UAP disclosure for years. He helped bring the famous Navy videos to public attention back in 2017, working with journalists to publish footage that forced the Pentagon to admit UAP are real and being tracked by military assets. Recently at the Soul Foundation event, he made a statement that got attention in UFO research circles, but barely registered in mainstream coverage. The world is not ready for what disclosure will reveal. Not aliens confirmed, not spacecraft recovered, just not ready. The phrasing suggests he knows more than he's saying, which is expected given his background and continued access to classified briefings, but it also suggests that whatever the truth is about UAP and potential non-human intelligence, the revelation would fundamentally challenge how we understand reality, consciousness, our place in the universe. Big enough that preparations for disclosure involve more than just press conferences. You need institutional frameworks, psychological preparation, cultural adaptation to paradigm shifts that make Kaepernick revolution look modest. Maybe that's why whistleblowers face retaliation, not because what they're saying is false, but because saying it before infrastructure is ready to handle public response creates chaos nobody knows how to manage. You can't tell billions of people that non-human intelligence has been interacting with Earth for decades or centuries and expect calm, rational integration of that information. You get panic, existential crisis, collapse of worldviews that structure entire civilizations. Better to slow-roll disclosure, leak information gradually, let culture adapt incrementally so that when official confirmation finally comes, it feels like validation rather than revelation. Or maybe whistleblowers face retaliation because they're wrong and institutions are protecting signal from noise. Preventing misinformation from contaminating legitimate aerospace research could go either way, but tomorrow brings potential clarification from an unexpected direction. If 3 Atlas is technological, if perihelion passage reveals capabilities that confirm artificial origin, that's disclosure from outside institutional control. No press conference is needed. No government announcement required. The data simply exists, recorded by multiple independent observers, analysed by scientists who don't answer to defense departments or intelligence agencies, truth emerging through observation rather than being released through controlled channels. That might be why the observation window was supposedly invisible. Why we were told perihelion would be hidden. If something significant was expected to happen, if institutional actors knew or suspected 3 Atlas might demonstrate non-natural behaviour. Keeping that moment hidden from independent observation would prevent uncontrolled disclosure. Let the object manoeuvre in darkness, collect classified tracking data, decide how and when to share information based on what protocols demand rather than what telescopes revealed. Except amateur astronomers proved the darkness was illusory. Perihelion is visible. Observation will happen, and whatever 3E Atlas does tomorrow becomes public record immediately. Impossible to classify retroactively, available for analysis by anyone with expertise and interest. Sometimes the most important disclosure isn't official statement, it's just careful observation of reality. Letting evidence speak for itself. Trusting that truth needs no institutional permission to exist, Webb's new wonders. While 3 Atlas captures attention with its dramatic approach, the James Webb Space Telescope continues revealing universes within the universe we thought we understood. Every image it captures, every spectrum it records, every observation it makes seems designed to humble our assumptions about cosmic order. The latest discoveries arrived just days ago. Almost as if the cosmos wanted to remind us that mysteries don't require interstellar visitors. Sometimes they're baked into the structure of reality itself, hiding in plain sight, waiting for instruments sensitive enough to notice. October 27th, 2025. 2 PhD students from the University of Sydney published software that restored the telescope's crystal clear vision after discovering subtle electronic distortions affecting one of Webb's instruments. Louis Dwass and Max Charles developed an artificial intelligence-driven system called Amigo that corrects image blurring in the infrared camera, fixing problems that would normally require astronauts visiting the telescope in space for physical repairs, except Webb orbits 1.5 million kilometers from Earth at the second range point. L2 completely unreachable by human missions with current technology. What breaks at L2 stays broken unless you can fix it remotely. The problem involved the aperture masking interferometer, the only Australian-designed component on Webb created by Professor Peter Tutel specifically for ultra-high-resolution imaging of stars and exoplanets. The instrument works by combining light from different sections of Webb's main mirror, using interferometry to achieve angular resolution far beyond what the mirror diameter alone would provide. But faint electronic distortions in the infrared detector were degrading performance, introducing artifacts that blurred fine details and reduced effective resolution. Traditional approaches to fixing this would involve uploading new calibration files or adjusting instrument parameters. Iterative process taking months, potentially never reaching optimal performance. Duois and Charles took a different approach. Train machine learning algorithms to recognize the distortion patterns. Model how light should actually look without electronic interference. Reconstruct true images from degraded data. The AI learned what real sky looks like versus what detector artifacts look like. separated signal from noise, recovered detail that was there in the photons but getting lost in conversion to electronic data. The results are spectacular. Galaxy NGC 1068 Jupiter's Moon TUEO, Wolf-Rayet Star 137, all previously captured with slight blur, now rendered in perfect clarity with detail visible down to the diffraction limit of the telescope. This isn't enhancement in the science fiction sense, where computers magically reveal hidden information. This is correction, removing known sources of degradation, restoring what the telescope actually saw before electronics corrupted it. And this matters enormously for 3A Atlas observation. Webb looked at the interstellar visitor back on August 6th with its near-infrared spectrograph instrument. The spectroscopy revealed that extreme carbon dioxide to water ratio, the 8:1 composition that makes the object so unusual. But spectrography is just one capability. Webb can also image in infrared wavelengths in visible-to-visible light telescopes, capturing thermal emission and reflected starlight in ways that reveal structure geometry details that might distinguish natural from artificial. If Webb turns towards 3 Atlas again post-perihelion, if the observatory dedicates time to detailed infrared imaging using the now perfectly calibrated interferometer, we might see things no other telescope can capture. Surface features, if any, exist. Geometric patterns in the coma that suggest organized rather than chaotic emission. Thermal signatures that don't match simple solar heating. Small secondary objects, if anything, deployed during perihelion passage. The level of detail Webb can achieve, especially with Amigo correcting for instrumental artifacts, approaches what you'd need to definitively characterize unusual morphology. But while the Sydney team fixed Webb's vision, the telescope itself kept making discoveries that challenge everything we thought we knew about cosmic history. 300 galaxies that shouldn't exist. That's what astronomers at the University of Missouri found when analyzing deep field images from Webb's infrared camera. Objects in the early universe formed within the first billion years after the Big Bang, appearing far brighter than they have any right to be. Standard galaxy formation models say you start with dark matter, gravitational wells pulling in hydrogen and helium, gradual accumulation, slow ignition of first stars, millions of years to build substantial stellar populations. Early galaxies should be small, dim, struggling to accumulate mass against the expansion of space itself. These objects are none of that. They're luminous, massive, structured in ways that require mature stellar populations and significant time to develop. Time they shouldn't have had. If the universe is 13.8 billion years old and these galaxies appear as they were 13 billion years ago, they had maybe 700 million years to form. Not enough time under current models. Not nearly enough. Ho-Jing Yan, astronomy professor at Missouri and co-author on the study, calls them candidate galaxies because confirming their nature requires follow-up spectroscopy that hasn't been completed yet. They could be very early galaxies that force revision of formation theories, or they could be something else entirely. Bright quasars, unusual dust emission, foreground contamination that looks like distant objects but isn't. Science requires confirmation before revolution. But if even a fraction of these 300 objects turn out to be actual galaxies at the distances their brightness suggests, we have a problem, a beautiful problem, the kind that overturns textbooks and launches decades of new research, but a problem nonetheless. You can't form massive bright galaxies in 700 million years using processes we understand. Either dark matter behaved very differently in the early universe, clumping much faster than models predict, or star formation was far more efficient than current physics allows, or something else entirely was going on that we haven't theorized yet. This is the third or fourth time Webb has found objects that defy standard cosmology. First, there were the little red dots, compact, extremely luminous sources that might be galaxies or might be a new class of object called black hole stars, where entire stellar masses get trapped in accretion disks around supermassive black holes. Then there were the impossibly mature galaxies at cosmic dawn, showing heavy element abundances that require multiple generations of stellar evolution despite appearing only a few 100 million years after the Big Bang. now 300 more objects too bright for comfort, pattern starts to emerge. Either our timeline for cosmic structure formation is completely wrong, compressed by factors we don't understand, or the early universe was fundamentally different from the later universe in ways that current theory doesn't capture. Hot Big Bang cosmology works spectacularly well for explaining cosmic microwave background, element abundances, large-scale structure today. But maybe the first billion years operated under different rules that we can't directly observe, because light from that era is only now reaching us in wavelengths infrared enough for Webb to detect. Meanwhile, Webb found interstellar dust with structure so fine it looks like wood grain. Knots and whirls and layers like an onion revealed when the telescope image light echoes from Cassiopeia supernova. The star exploded 350 years ago. The blast wave has been expanding ever since and recently reached interstellar material that wasn't part of the original explosion. When that flash of X-rays and ultraviolet light hit the dust, it heated it, made it glow in infrared, and Webb captured the emission in unprecedented detail. Josh Peake from the Space Telescope Science Institute describes seeing structure on scales of 400 astronomical units, less than 1/100th of a light year. Sheet-like formations, tightly packed filaments, structures so organized they look like they must be shaped by magnetic fields threading through the interstellar medium. We knew interstellar space wasn't empty, knew it was full of gas and dust, but we didn't know that dust had architecture, organization down to incredibly small scales, geometry that suggests forces we barely understand, sculpting the matter between stars into forms we're only just beginning to see. This matters for 3I Atlas, because the object is shedding mass. 2 million tons of material lost between July and October as solar heating sublimates surface layers. That material doesn't vanish. It becomes part of the interstellar medium. Microscopic ice fragments and dust grains drifting through space, contributing to the architecture of the galaxy. If 3E Atlas is natural, its dust joins the ordinary interstellar material that Webb sees organized into sheets and knots. If it's artificial, the dust might have signatures, unusual composition or isotope ratios or grain sizes that don't match natural solar system formation. Decades from now, when that dust disperses, some of it will still be out there, potentially identifiable, potential evidence of the object's nature, preserved in particles scattered across light years. The universe Webb reveals is messier than we expected, more chaotic in some ways, more structured in others. Galaxies form faster than they should, get brighter than they should, contain heavy elements sooner than they should. Interstellar dust organizes into geometric patterns despite being influenced by turbulent flows and magnetic chaos. Black holes exist in the earliest epochs when there shouldn't have been time for them to grow supermassive. Stars explode and leave echoes that illuminate architecture we never knew existed. Every answer generates more questions. Every observation opens new mysteries, and running through all of it is the uncomfortable recognition that we understand maybe 5% of what the universe contains. Dark matter makes up most of the mass. Dark energy drives accelerating expansion. Normal matter, the stuff we're made of, the atoms that form stars and planets and people, represents a small minority of cosmic inventory. And even that small minority behaves in ways we struggle to predict when we look at scales Webb can now access. This is the context for 38, an interstellar visitor arriving in a universe that's already mysterious, already full of phenomena we can't explain with standard physics already demonstrating that our theories work well locally, but struggle with extremes of time and distance and energy. If the object turns out to be artificial, it'll be surprising but not uniquely impossible. Just another thing the cosmos can do that we didn't anticipate. Another way intelligence manifests in a universe that seems designed to produce complexity despite or because of physical laws we think we understand. But even if 3I Atlas is natural, even if tomorrow brings conventional comet behavior and the technological hypothesis evaporates, we're still left with a universe that contains 300 impossibly bright galaxies, dust organized like living wood, early black holes that shouldn't exist, and formation timelines that violate our best models. The mystery doesn't depend on aliens. It's baked into the structure of space and time and matter. Webb gives us the tools to see that mystery in detail: infrared sensitivity, spectral resolution, angular precision, distance reach that brings the edge of observable universe into focus. Every technical advance reveals more questions, and the telescope has barely begun its operational life. 20 years of observation time ahead. Decades of discoveries waiting. Fields of view we haven't targeted yet. Objects we haven't noticed yet. Phenomena we don't have names for yet. And somewhere in those future observations, maybe we'll find more interstellar visitors. Objects like 3 Atlas passing through, some natural, some potentially artificial, all carrying information about planetary systems we'll never visit, and stellar neighborhoods we can only study through the emissaries they send our way. Statistics suggest 1 or 2 interstellar objects per year should pass close enough for detailed study if our detection capabilities are good enough. Webb makes those capabilities better. Ground-based observatories continue improving. Survey telescopes scan larger volumes of sky with greater sensitivity. The golden age of interstellar visitor detection is just beginning. 3 Atlas is the third we've confirmed, but it won't be the last. And as our characterization improves, as spectroscopy and imaging and trajectory analysis become routine for every detection, we'll build a catalogue: natural versus artificial, compositions, trajectories, size, distributions, enough data points to draw statistical conclusions about what travels between stars and whether intelligence is part of that traffic. That's the real test. Not one object, not 3i Atlas in isolation, but dozens or hundreds of interstellar visitors studied over decades, analysed for patterns compared against theoretical predictions for both natural and artificial populations. If technological probes exist, if civilizations send scouts between stars at rates higher than natural ejection, produces random comets and asteroids, the statistical signature will emerge. Too many visitors with suspicious trajectories, too many alignments with ecliptic planes and planetary encounters, too many anomalies that individually might be chance but collectively indicate design. We're not there yet. We don't have enough data, but we're approaching the threshold where statistical arguments become possible, where catalogue science replaces case studies, where patterns override individual ambiguity. Tomorrow 3.2 Atlas adds another data point: natural or artificial, conventional or anomalous, explicable or mysterious. The measurement gets recorded, the data joins the archive, and the universe continues revealing itself layer by layer, mystery by mystery, one observation at a time. The dark search, 33,000 light years. That's how far away the closest alien civilization might be. According to the latest analysis from the Austrian Academy of Sciences, not next door in cosmic terms, not even in our neighbourhood, but a distance that makes the Fermi paradox, that haunting question about where everybody is, feel less like paradox and more like simple geometry. Space is big, really big, and intelligence might be rare enough that the nearest examples are scattered across distances that make communication essentially impossible. Even if both sides are trying, Manuel Schurf and Helmut Lama published their analysis in October, same month. 3 Atlas reaches perihelion, same timeline when conversations about extraterrestrial intelligence move from academic exercise to potentially urgent practical concern. Their methodology is straightforward but sobering. Start with what we know about planet formation, add constraints for habitability, factor in the requirements for complex life to emerge and survive long enough to develop technology. Calculate how many stars in the galaxy might host worlds meeting all criteria. Divide galactic volume by that number. Get average distance between civilizations. 33,000 light-year emerges from conservative estimates. Could be closer if we're lucky. Could be farther if conditions for technological intelligence are more stringent than models suggest. But 33,000 light-year is the median prediction. The distance you'd expect if extraterrestrial intelligence exists at all. but remains extremely rare. That distance creates interesting problems for the interstellar visitor hypothesis. If the nearest civilization capable of sending probes is 33,000 light-years away, and probes travel at maybe 10% light speed if we're being wildly optimistic about technological capability, the journey time is 330,000 years, longer than modern humans have existed, longer than any human civilization has persisted, longer than most species survive before extinction or evolution, transforms them into something else. So, either probes travel much faster than we think possible, maybe approaching significant fractions of light speed using physics we haven't discovered yet, or the probes are ancient beyond comprehension, launched hundreds of thousands or millions of years ago by civilizations that might not even exist anymore, drifting through the galaxy on autopilot, still executing survey missions programmed into them before Earth had language or cities or fire, or the distance estimate is wrong. Maybe intelligence is more common than Surf and Llama calculate. Maybe the filters they apply, the requirements for plate tectonics and stable carbon dioxide cycles and planetary magnetic fields and all the other factors that make Earth unusual are too stringent. Maybe life finds ways around those constraints. Maybe intelligence emerges under conditions we haven't considered because we're biased by the one example we know. The carbon dioxide constraint is particularly interesting given 3A-TL composition. Scherf and Delmar emphasize that planetary atmospheres need specific carbon dioxide levels to sustain complex life. Too little, and you can't maintain greenhouse warming or support photosynthesis. Too much, and you get runaway greenhouse effect or toxic atmosphere that kills everything. The Goldilocks zone for carbon dioxide is narrow, and maintaining it requires plate tectonics to recycle carbon between atmosphere and crust through the carbon-silicate cycle. But 3-2 Atlas has extreme carbon dioxide dominance 8:1 ratio relative to water. If that composition reflects the environment where it formed, the parent system had very different chemistry than ours, cold enough that carbon dioxide ice is a primary component, which might mean planets there are carbon dioxide rich rather than water rich, which might mean any life that emerges would be adapted to carbon dioxide biochemistry rather than water-based biochemistry we consider essential. Pure speculation, but it raises the question. When we calculate how common habitable planets are, we use Earth as template. Water oceans, oxygen, atmosphere, temperature range where water stays liquid. But what if habitable just means conditions where complexity can persist and evolution can operate? What if carbon dioxide worlds support their own biospheres using chemistry we haven't theorized? What if the 33,000 light-year estimate is based on finding Earth analogies when the galaxy might be full of worlds, nothing like Earth, that still produce intelligence? We won't know until we find examples. And finding examples requires looking brings us to SETI, the search for extraterrestrial intelligence, and the uncomfortable fact that despite 60 years of listening, we've heard nothing definitive. Lots of noise, occasional intriguing signals like the wow event, but nothing repeatable, nothing clearly artificial, nothing that survived follow-up observation and proved to be genuine communication from another technological civilization. The silence is either evidence of rarity, intelligence so uncommon that detectable signals are vanishingly sparse, or evidence of methodology failure. We're looking in wrong places at wrong frequencies using wrong assumptions about how advanced civilization might communicate. Radio made sense when we started CT in the 1960s because radio was our cutting-edge communication technology. We assumed anyone advanced would use radio too, probably at hydrogen line frequency, because that's a universal constant any astronomer would recognize. But we've already moved beyond radio for most communication. Fiber optics, laser links, quantum encryption, technologies that don't broadcast omnidirectionally into space, but instead focus narrow beams point to int for efficiency and security. If we're abandoning radio after barely a century of using it, why would civilizations millions of years more advanced still be broadcasting radio signals loud enough for us to detect across interstellar distances. Maybe they use neutrinos, particles that pass through matter almost without interaction, perfect for communication across galactic medium filled with gas and dust and plasma that distorts electromagnetic signals. We can barely detect neutrinos with massive underground detectors. Modulating them for communication is beyond our current capability. But a civilization that's had 1 million years to develop physics probably figured it out. Or maybe they use gravitational waves, ripples in space-time itself, completely immune to electromagnetic interference, propagating at light speed through empty space. We just developed detectors sensitive enough to register black hole collisions and neutron star mergers. Deliberately modulating gravitational waves for communication is theoretically possible, but requires technology that manipulates massive objects or energy densities we can barely imagine. Yet, for a sufficiently advanced civilization, maybe it's trivial. Or maybe communication isn't the point. Maybe advanced civilizations learned long ago that broadcasting your presence across interstellar space is dangerous. You don't know who's listening. You don't know what their intentions are. Better to stay quiet, monitor passively, send physical probes that can observe without announcing themselves. If the galaxy is filled with civilizations all hiding from each other, because nobody wants to be the first target when something predatory shows up. Radio silence makes perfect strategic sense. This is the dark forest hypothesis borrowed from Lucikson's science fiction, but increasingly taken seriously by researchers thinking about galactic sociology. If technological civilizations are common, but hostile encounters are possible, the optimal strategy is silence, observe, but don't reveal. Explore using stealth probes. Maintain informational advantage by knowing about others without letting them know about you. Under these conditions, interstellar space becomes a dark forest where every civilization is a hunter, moving carefully through the trees, and the first one to make noise gets targeted. 3E Atlas doesn't fit the stealth probe profile particularly well if it's artificial. It's been visible since discovery, bright enough for amateur astronomers to track, generating enormous amounts of gas and dust that make it conspicuous across millions of km. Not exactly covert surveillance. But maybe stealth isn't the goal. Maybe once you're detected, the strategy shifts. Let them think you're natural. Comet behavior provides perfect camouflage. Even if some observers suspect artificial origin, lack of definitive proof keeps the question ambiguous, prevents panic, allows continued observation while assessment proceeds. Or maybe the dark forest hypothesis is paranoia. Maybe most civilizations that survive long enough to become interstellar are peaceful, cooperative, interested in exploration and knowledge, rather than conquest and exploitation. Maybe the galaxy is friendly and we just haven't heard the conversation yet because we're too young, too primitive, too isolated in a backwater star system that doesn't get much traffic. The biosignature detection on exoplanet K28b adds another layer to this conversation. James Webb Telescope spectroscopy found a methyl sulfide DMs in the atmosphere with 99.7% confidence. On Earth, DMs is produced primarily by biological processes. Marine phytoplankton generate it. It's considered a potential bioarcher, a molecule that suggests life, even if it doesn't prove life. But DMs can also form through non-biological chemistry. It's been detected on Comet 67P and in interstellar medium. Ultraviolet light shining on simulated atmospheres can produce it, so finding it on K218b, an exoplanet 124 light-years away, doesn't confirm alien life. It confirms interesting chemistry that requires further investigation. Still, it's progress. A decade ago, we couldn't characterize exoplanet atmospheres at all. Now we're detecting specific molecules and assessing whether they might indicate biology. Another decade of refinement, better instruments, more sensitive spectroscopy, and we might be able to distinguish between biological and abiotic production based on abundance patterns and associated chemistry. Find enough biosignature molecules in combination that non-biological processes can't easily explain, and you have strong evidence. even without direct observation of organisms. K218b is a mini Neptune, much larger than Earth, probably doesn't have a solid surface, unlikely to support life as we know it, but its atmosphere might host microorganisms floating in clouds, harvesting energy from chemistry, reproducing in droplets. We don't have examples of aerial biospheres in our solar system, but physics doesn't forbid them. And if life can exist in atmospheres, the number of habitable environments in the galaxy expands dramatically. Every gas giant, every sub-Neptune, every world with thick atmosphere becomes potential habitat regardless of whether solid surface exists underneath. That changes the 33,000 light-year estimate. Add atmospheric habitats to the calculation. Include worlds we previously dismissed as uninhabitable. Suddenly, the galaxy might support far more biospheres, and if life is more common, intelligence becomes more probable, even if the transition from simple to complex to technological remains rare. But finding biosignatures doesn't tell us about intelligence. Microorganisms might be common. Complex multicellular life might be rarer. Technological civilizations rarer still. You could have a galaxy full of bacterial biospheres with only occasional examples of intelligence scattered across such vast distances that contact becomes statistically unlikely during any civilization's technological lifespan. This is the pessimistic resolution to FM's question. Life is common. Intelligence is rare, and the rare intelligence that do emerge are separated by distances and timescales that prevent meaningful interaction. You might have 1 million technological civilizations in the galaxy at any given moment. Sounds like a lot. But spread across 400 billion stars in a disk 100,000 light-years across. Average distance between civilizations becomes tens of thousands of light-years. Communication round-trip times measure in hundreds of thousands of years. Impossible to maintain dialogue. Barely possible to confirm detection before one civilization or the other collapses into extinction or transforms into something post-biological that no longer cares about communication. Under those conditions, physical probes become the only realistic option for learning about neighbours. Send automated scouts programmed to explore, catalogue, report back. Travel times measure in hundreds of thousands of years, but probes don't care. They're not alive in ways that make lifespan relevant, just hardware executing mission parameters, waiting for interesting systems, activating when they find promising worlds, gathering data, however long that takes. If civilizations deploy probes at steady rates over millions of years, the galaxy gradually fills with reconnaissance craft, some still functioning, some failed and drifting as debris, some so ancient they're geological artifacts on planets they surveyed eons ago. The cumulative population could be enormous even if individual civilizations are rare, because probes persist long after makers are gone. This is the hypothesis that makes 3 Atlas potentially significant, not as the first probe ever, but as the first one we're technologically sophisticated enough to recognize might not be natural. We've probably been visited before multiple times. Objects passing through the solar system, observing from distance, moving on to next target. We just weren't looking. Didn't have instruments sensitive enough to detect them. Didn't have theoretical frameworks that predicted interstellar visitors. Assumed everything in our sky was either local or impossibly distant galaxies. The possibility of something in between, objects from other stars passing through occasionally, wasn't on our conceptual radar until Oumuamua in 2017 forced us to recognize interstellar visitors are real and detectable. Now we're watching. Every unusual trajectory gets investigated. Every object that doesn't fit solar system formation gets spectroscopy. And maybe eventually we'll spot something that's unambiguously artificial. Not comet, not asteroid, hardware, technology. Proof that someone else figured out how to cross the dark between stars. Tomorrow, 3IE Atlas might provide that proof, or it might just be a comet, natural and explicable, teaching us about planetary formation in other systems, but offering no evidence of intelligence beyond Earth. Either way, the search continues. SETI keeps listening, telescopes keep scanning, exoplanet characterization keeps improving, biosignature detection keeps refining, And somewhere out there, 33,000 light-years away, or 33 million light-years away, or right next door in our cosmic backyard, someone else might be doing the same thing, listening to the silence, watching the darkness, wondering if anyone else is out there wondering the same thing. Maybe we'll never meet them. Maybe the distances are too vast or the timescale's too long. The chance is too slim. But we'll keep looking because the alternative, assuming we're alone without checking, feels like giving up on the most important question intelligence can ask. Are we the universe's only attempt at understanding itself? Or are we one voice in a chorus so vast and scattered that hearing each other requires patience and technology and luck we're only beginning to develop? The dark forest might be full of hunters, all hiding from each other in paranoid silence. Or it might be full of civilizations who desperately want to talk but don't have the technology to bridge the gaps between them yet. Or it might be genuinely empty with us as the first intelligence to emerge in this corner of the galaxy, responsible for whatever comes next because there's nobody else to ask for guidance. Tomorrow won't answer that question, but it might give us data that makes the answer feel closer, might provide evidence that tips probability slightly toward we're not alone or slightly toward we probably are. And in science, slight tips compound over time. Enough data points and uncertainty resolves. Enough observations and patterns emerge. Enough patience in the universe eventually tells you what you need to know. Government in the Shadows, September 30th, 2025. That was the deadline. Every federal agency required to review, identify, and organize their UAP records for transfer to the National Archives, the Unidentified Anomalous Phenomena Records Collection. Record Group 615 established by the 2024 National Defense Authorization Act, specifically to consolidate decades of scattered documentation about sightings, encounters, investigations, everything the government knows about objects in our airspace that don't fit conventional explanations. Tomorrow is October 29th, 1 month past deadline, and the collection remains sparse. Some agencies transferred documents, mostly declassified reports from the 1950s and 60s Project Blue Book era material that's been available through Freedom of Information requests for years. Historical curiosities, nothing current. Nothing sensitive, nothing that would challenge the narrative that UAP are either misidentifications, classified aircraft, or phenomena we don't understand yet, but definitely aren't alien spacecraft. Christopher Mellon, former Deputy Assistant Secretary of Defense for Intelligence, has been pushing for transparency harder than almost anyone in the disclosure movement. He knows the classification system from inside, knows what gets hidden and why, knows that legitimate national security concerns sometimes justify secrecy, but other times secrecy is just institutional inertia, organizations protecting information because releasing it would be embarrassing or inconvenient, or would raise questions they don't want to answer. His recent statement at the Sol Foundation event keeps getting quoted. The world is not ready for what disclosure will reveal. Not ready, present tense, as if disclosure is inevitable. Just a matter of timing, and the delay is about preparation rather than permanent concealment. But preparation for what if UAP are all mundane misidentified aircraft or weather balloons or drones or atmospheric phenomena? There's nothing to prepare for. You release the data, show that every case has prosaic explanation, and the mystery evaporates. Speculation ends, people move on, no crisis, no paradigm shift. Just closure on a question that's been generating conspiracy theories for decades. But if UAP include genuine unknowns, objects that demonstrate capabilities beyond current human technology, operated by someone or something that isn't any nation's military or commercial sector, then disclosure becomes complicated. You're not just admitting that strange things fly in our skies, you're admitting that we don't control our own airspace, that there are entities, human or otherwise, with technology that outperforms our best systems, that the fundamental assumption of territorial sovereignty that nations can secure their borders and monitor their skies isn't actually true. That admission has consequences. military consequences if adversaries have capabilities we can't match, political consequences if leadership has been unaware or unable to respond, psychological consequences if the objects aren't adversaries at all, but representatives of non-human intelligence that's been observing Earth without asking permission. Mellon's phrasing suggests the last scenario. Not ready doesn't mean not ready to admit we missed some classified aircraft. It means not ready to accept that humanity's position in the cosmos is different than we believed, that we're not alone, that we're not the most advanced intelligence in our immediate neighbourhood, that Earth has been under observation possibly for longer than we've had technological civilization. And we didn't notice because the observers were subtle, or we weren't looking, or we dismissed evidence that didn't fit comfortable worldviews. The institutional resistance to disclosure makes more sense in that context. This isn't just releasing embarrassing documents about past misidentifications. This is managing the revelation that fundamentally changes how humans understand their place in the universe. You don't drop that information casually. You prepare infrastructure, coordinate messaging across governments, establish frameworks for how society processes the information without collapsing into panic or denial or conflict. But how do you prepare for that? How do you ready 8 billion people for news that intelligent life exists beyond Earth? And it's here observing present in our airspace with technology we can't replicate. There's no historical precedent, no playbook. Every past first contact scenario involved humans meeting other humans, different cultures and technologies, but same species, same biological limitations, same basic psychology. Contact with non-human intelligence is categorically different. We don't know how to communicate with minds that evolved under completely different selection pressures, don't know their intentions, don't know if concepts like diplomacy or trade or peace even translate to their cognitive frameworks. So maybe delay is pragmatic. Extend the preparation period. Use the time to build international consensus on how to handle contact scenarios. Establish protocols for communication attempts. Develop contingency plans for hostile or indifferent responses. Let culture gradually acclimate through science fiction, through incremental revelations about exoplanets and biosignatures and the statistical likelihood of extraterrestrial life. Slow roll the reality so that when official confirmation finally comes, it feels like inevitable conclusion rather than shocking revelation. That strategy assumes control over information flow, assumes that institutions can decide when and how to release confirmation. But 3 Atlas demonstrates the flaw in that assumption. Interstellar visitors don't coordinate with government press offices. They arrive on trajectories determined by orbital mechanics and origin points light years away. And when they do something observable, something that amateur astronomers with backyard telescopes can detect and document and share immediately online, institutional gatekeeping becomes irrelevant. The information is public before official channels can evaluate whether to classify it. This is what terrifies intelligence agencies about the democratization of observation technology. 60 years ago, tracking interstellar visitors required dedicated observatories with professional staff and government funding. You could control that infrastructure, classify the findings, decide what reaches public awareness. But now, anyone with a few zeros 00 can buy telescope, camera, tracking software that rivals what professionals had in the 1980s. And anyone with internet connection can share observations with global audience within minutes of capture. Can't classify what was never classified to begin with, can't suppress what's already distributed, can't control narrative when narrative forms from crowdsourced data aggregation across thousands of independent observers who don't coordinate with anyone except each other. The Earth Exists blog post proving 3 Atlas remains visible during perihelion is perfect example. Amateur group consumer equipment publicly shared observations complete with images and coordinates. Within hours, other observers were attempting verification. Within days, the visibility controversy was mainstream topic in astronomy forums and social media. No institutional involvement, no approval process, just direct observation and immediate publication. That's the new normal for disclosure. It doesn't come from press conferences or government announcements. It comes from people pointing instruments at the sky and sharing what they see. If 3i Atlas maneuvers tomorrow, if course corrections happen or brightness spikes or anything occurs that indicates non-natural behaviour, dozens of observers will capture it. Multiple data sets will emerge independently. Analysis will happen in parallel across different research groups, and consensus will form not from institutional authority declaring truth, but from weight of evidence that can't be explained away. This is citizen science at its most disruptive and its most powerful. No funding requirements, no institutional approval, no hierarchy beyond expertise and evidence quality, just observation, analysis, peer review happening through informal networks that operate faster than traditional academic publishing. When something interesting happens, documentation and preliminary analysis can be online within hours. Global collaboration can confirm or refute findings within days compared to months or years for formal publication process. The National Archives collection deadline was supposed to centralise UAP information, create single authoritative repository, let researchers access historical data, analyse patterns, draw conclusions based on complete records rather than fragmented leaks and Freedom of Information Act requests. Good idea in principle, but the deadline passed with minimal compliance. Agencies transfer token documents while withholding anything sensitive, and the sensitive material is where real answers might be hiding. Mellon has talked about this problem extensively. The intelligence community reclassified almost everything related to UAP after the Navy videos leaked in 2017. Material that was previously unclassified, documents that researchers had accessed suddenly became restricted. The justification was protecting sources and methods. Can't reveal how we detected these objects or what sensors captured the data, because adversaries would learn our capabilities. But that justification only works if the objects are adversary technology. If they're not human at all, if they're visitors from elsewhere, operating with capabilities so far beyond ours that knowing our detection methods wouldn't help them evade surveillance, then classification serves no protective purpose. It just keeps information from public and congressional oversight without legitimate security rationale. This creates impossible situation for whistleblowers. They see something. They know it's significant. They want to report through proper channels, but proper channels lead to classification and burial. If they report, the information disappears into classified databases where it can't be independently verified or acted upon. If they don't report, they're neglecting their duty to document anomalous events that might represent threats or opportunities. And if they go public without authorization, they face retaliation, career destruction, legal prosecution, social marginalization. The system is designed to prevent unauthorized disclosure, even when authorized disclosure is impossible because gatekeepers refuse to declassify information that should be public. David